Welcome to Mrs. Z's Chemistry. In this video, we will continue our topic on 5.2, which is calorimetry. Calorimetry is the technique we use to measure the amount of heat that is transferred from the system to the surroundings or vice versa from the surroundings to the system. In our last lesson, we discussed this concept from the context of having a hot piece of metal being dropped into a cold amount of water. In this in this lesson, we are going to learn about this concept from the system being a chemical reaction and the solution is the surroundings. These chemical reactions are in the aqueous form, which means dissolved in water. So the water that the chemicals are dissolved in is the solution / surroundings. So we have Q of reaction plus the Q of solution is equal to 0, or rearrange this algebraically, and we have Q of reaction is equal and opposite to Q of solution. This means that the amount of heat produced or consumed by the reaction equals the amount of heat absorbed or lost by the solution. Here's our first example. When 50 milliliters of 1 molarity HCl or hydrochloric acid solution and 50 milliliters of a 1 molarity NaOH or sodium hydroxide solution, both at 22 degrees Celsius, are added to a coffee cup calorimeter, the temperature of the mixture reaches a maximum of 28.9 degrees Celsius. What is the approximate amount of heat produced by this reaction? So here's the reaction that we have. It is balanced. When we write HCl with aqueous after, or AQ, that means we have HCl dissolved in water. We don't have pure hydrochloric acid. We have hydrochloric acid, which is dissolved in water. NaOH is also dissolved in water. So when you have two beakers or two containers, each containing 50 milliliters of each of these respective chemicals, we have that 50 milliliters is counting the water that it's dissolved in. So then when you add these two together, we have a total of 100 milliliters. That is the mass of the whole reaction. But then when you combine the two reactants, this becomes the solution. And so we have the same mass for both the reaction and the solution. So here's our mathematical equation again. Q of reaction is equal and opposite to Q of solution. This is saying that the amount of heat that the reaction produces is the same amount of heat that the solution absorbs. And in the problem, when it says that the temperature of the mixture reaches a maximum of 28.9 degrees Celsius, that is coming from our thermometer is sitting in the solution. The thermometer is measuring the temperature of the surroundings. This equation here is not saying that the solution has negative heat. Mathematically, it doesn't matter which side the negative sign is on. Just one of the sides needs to have a negative sign so that we say one part is losing the heat, the other is gaining that heat. So here's a continuation of the explanation. So because the reaction mass is the same as the solution mass, and the specific heats are the same because we're just going to use the specific heat for water for both the reactants, and then after you mix them together, we still essentially have water, and so the specific heat will be the same for water. So in this case, we're just going to find the Q of solution, which has the same equation here, Cm delta T of the solution. So our C is going to be the specific heat of water. And then the mass is 1 times 10 to the 2, or 100 grams. This right here is the value of 100 grams. And then our final temperature is 28.9, and initial temperature is 22. So when we multiply these together, we have 2.9 times 10 to the 3 joules, and that is the amount of energy that's absorbed by the solution. The solution absorbed it because the temperature increased. Now, the only thing we have to remember is that when this problem is asking for the amount of heat produced by the reaction. So it's coming from the perspective of the reaction. The reaction is equal and opposite to the Q of the solution. So our 2.9 times 10 to the 3 joules becomes negative 2.9 times 10 to the 3 joules, and that is the Q of the reaction. The negative sign indicates that the reaction is exothermic. Exothermic reactions release or produce heat. Let's look at a different example, but similar idea. When solid ammonium nitrate dissolves in water, the solution becomes cold. This is an ice pack. When 3.21 grams of solid ammonium nitrate dissolves in 50 grams of water at 24.9 degrees Celsius in a calorimeter, the temperature decreases to 20.3 degrees Celsius. calculate the value of Q and explain the meaning of the sign. The amount of heat produced or consumed by the reaction equals the amount of heat absorbed or lost by the solution. So, for our answer, first we can remember that Q of reaction is equal and opposite to Q of solution. Because both the solution and the reaction have the same mass and the same specific heat, we can say that the Q of solution is solved by finding Cm delta T of the solution. See if you can plug in our variables, all the values for the different variables that we have given in the problem. So we have 4.184 for the specific heat, and then 53.2 grams. These grams comes from adding up the mass of the water plus the mass of the ammonium nitrate. That was 50 plus 3.21. And then the final temperature is 20.3, and the initial is 24.9. So this actually should show, this is Q of reaction. The RXN stands for reaction. The Q of the reaction is going to have a positive value because the reaction absorbed the energy, and that is why the surrounding solution decreased in temperature, because that energy came from the water that was surrounding the reaction. The explanation for the sign is that the positive sign for Q indicates that the dissolution or dissolving process is an endothermic process, because endothermic processes absorb or gain heat.